I'm here with Jesus today to discuss about MLOps. Without the overwhelm, what do we need with that? We will try to demystify a bit the topic. I will start with an introduction, what is MLOps and why do you need it? And then Jesus will walk you through how you can start implementing it right now. So let's start. We live in the era of models. We wanted to open the talk with a bit of a catchphrase. I hope you are impressed. What do we mean by that? Well, I think you noticed that lately there is a lot of hype around AI. Everybody's talking about AI. Everybody wants to do something with AI. One example of this, well, it's LLMs. I think you know them. But one interesting phenomenon that we want to discuss is that in these recent years, the focus of AI discussion moved a lot towards the model. 2-3 years ago, the focus was more about AI applications. Nobody was discussing models. You wouldn't hear two non-technical people saying something like, hey, did you see the new decision tree model made by this company? Nobody really cared. They just wanted the value. Now everybody's discussing like GPT, cloud, so the actual model is the center of the discussion. We're not here to talk about LLMs. We want to talk about generic ML applications. But well, you see the same phenomenon also in generic ML application. When you discuss ML projects, a lot of people focus a lot on the model, as if it was the only thing that mattered in this case. Well, when the practice is actually quite different. When you get to implementation, you see that the model is something important, but around the model, there is a lot more that you need to take into consideration. Funny thing, every piece of this big puzzle comes with its own challenges, so you'll need to deal with them eventually. I'll show you some of the challenges. Just for example, okay, we can start from the model, performance degradation. Over time, your model might not perform as was performing at the beginning, and you don't know why, you don't know how to deal with it. Long training through production cycle. Maybe you're taking too much to put your AI use case in production, and this might become a problem. Non-reproducible training. Maybe your data scientists are doing their thing with their notebooks, but then you don't really know how to reproduce this and to track what they're doing. But then we move to another piece of the puzzle, quite important, data collection. A lot of challenges comes with that. Data drift. How do you detect it? How do you deal with it? Well, that's a discussion that you probably need to have. Hard to track feature changes. Again, you're doing some transformation, some feature engineering on your data. You don't really know when you did it, well, what you did it, and which effect did it have on the model. So it's something that you would like to keep track of. Another piece of the puzzle, serving infrastructure. This is often overlooked, but it's really important. A lot of people are like, just, I will use my cloud provider and everything will be fine. But you might be, for example, too slow in providing infrastructure. And this might become a problem, for example, for scalability of your use case. Or you also might be spending too much in infrastructure. And this is usually because you're not using your resources efficiently. These are just some examples of problems that you might have. I showed you before, the puzzle is quite big, and every piece comes with its challenges. Probably not all of them apply to your specific use case, but you need at least to acknowledge that these challenges can be there. And one of these challenges might be the reason that your use case doesn't perform too well, or also, even worse, doesn't make it to production. So quite important to know that these challenges exist. Maybe you still don't trust me that this is a problem, understandable, but I can show you some data. This is a recent study that found out that only 53% of ML projects make it into production, which means that basically half of them doesn't make it to production. It's quite a lot if you ask me. The number used to be even smaller. Now we're getting better, but there's still a long way to go. The main reason that they found is that companies actually lack the tools to deal with production-grade AI. And this comes back to the picture that I showed you before. You need a lot of tools to manage the whole puzzle of things that you need to for an AI use case. And companies are most of the time lacking those. So the problem is real, it's concrete. Now the question would be, how can we make sure that my use case is in the good 53% of project that makes it, or at least increase my chances of this happening? Well, you might have guessed it. This is where MLOps comes quite handy. There are multiple ways you can define MLOps. One of these is a set of practices that actually help you in doing what I just described. So bringing your ML use case throughout the whole life cycle. So designing, developing, and deploying it. This comes with multiple benefits. I'll just list some of them. Faster time to market, you want to at least go to a prototype to something in production as soon as possible, because you don't know anything until you deploy to production. For those who paid attention, is one of the core values of Dataminded. Better adaptability, you want your system to be adaptable to many things, to different data, to different user behavior, to different business requirements. You want to adapt as fast as possible, of course. More reliable system, of course, you want your system to behave as you expect. With ML, it's not always 100% possible. There is some variance, but you would like to reduce this variance as much as possible, at least. And then smaller time to recovery. Yeah? So reduce the downtime of your application and make sure that when there is a problem, you detect it early and you can act as fast as possible. So these are some of the advantages that a good implementation of MLOps could bring to your project. This is another way to visualize it. I like it a lot. Is just the intersection between machine learning, data engineering, and DevOps. Usually machine learning and data engineering are concepts quite known. DevOps is a bit more vague, and just to make sure that everyone is up to speed, I'll go through a bit what DevOps is. This is a quite famous image. You saw it from Yelena, something similar, so I will not spend too much time on it. But basically, you have two teams usually, development operations. They pull into two different directions because development like to write code and add features, while operation likes stability and want everything to work and nothing to change. So they pull in different directions. They don't really know what the other one is doing. They don't communicate well. There is this confusion wall. And also development really likes to just, hey, I've done this code, deal with it, throw it over the wall, and this usually doesn't end well for your project. So DevOps is all about destroying this wall, making development and operation cooperate, create this continuous cycle that goes from development to operation, back into development, and so on, over and over again. Important thing of DevOps is that the objective is to try and automate as much as possible in this cycle and to reduce friction so that you can iterate fast through it multiple times a day, a week, a month, depending on your organization. So we talk about DevOps, but the focus of the talk is actually MLOps. You can also see MLOps as an extension to DevOps. So the cycle is quite similar, but we add an extra loop to deal with everything ML related. So the model, the data, and everything that comes with it. What does this extra loop actually mean in practice? Well, it means that you can see MLOps as DevOps with extra challenges. There are some more things that you have to take into account when doing MLOps compared to just DevOps. I'll give you some of the examples. It's not an extensive list, but some of the more important are version control. When you talk about version control in the context of DevOps, it's usually about your source code. You want to version your code with something like Git. But in MLOps, there are two more dimensions that you need to take into account. You also want to version your model and your data. It's really important. And there are specific tools that can help you in this. For data, for example, DVC is a popular tool. For model, basically every model registry that your cloud provider gives you will do the job. It depends on your application. Another challenge is testing. In DevOps, usually deterministic tests. You just want to test that the code you made works as you expect. So unit test, integration test. In MLOps, a lot of times we enter the non-deterministic realm because you also want to test your model. So accuracy, fairness, and robustness are things that you don't really have a lot of power on them. So you need to take this into account when developing an MLOps project. Also, this is even more important because a lot of models now are black boxes, so you don't really know what's happening. And it's something that you eventually have to deal with it. And also, you have to do a lot of testing on data. Once again, this was discussed in the previous talk, so I will not go too much into detail. Automation pipelines. Well, DevOps is really famous for its CI/CD, continuous integration and continuous development. In MLOps, you also want to automatically train your model. So you add the continuous training CT pipeline, which is a key component of your ML use case. Last, the monitoring. DevOps, quite standard. You want to monitor your application, your logs, performance metrics, and it's quite standard how you monitor that. In MLOps, it's a bit more difficult because you also have to put a lot of effort in monitoring your model. So accuracy over time, drift, you want to detect this early and act on it as fast as possible. These are some of the examples, but so the main point is that, yes, MLOps is an extension of DevOps, but it comes with a lot of more things that you need to take into account, and you need to have the tools to deal with these things. I think that's it for the introduction. So now I'll leave the stage to Jesus, who can walk you through how to actually implement MLOps.
Thanks. Yes, so I hope that by this point in the talk, my colleague Mario has convinced you, like, okay, I need to use MLOps. But I think the last slide is really important. I don't know, I mean, the first time that you see a slide like that with so many things that you can do for MLOps, I would feel overwhelmed, like, where do I even start? You know, there are so many things that you can actually do that is like, I mean, I would say, yeah, fuck it, I'm not going to do it. But it's not that difficult, and that's why we are here today, okay? So the first thing is really remove all of these mystic things and then see how to do it. The first good news for us is that MLOps is not all or nothing, you know, it's not like either you do it or you don't do it. It's something that you can instead progressively make it as mature as possible. You know, you can start, here is where a lot of people are, you know, I'm running my notebooks, running experiments, I don't know what's going on really. There is no MLOps. And then you can say, okay, first, let's build a foundation. Let's add DevOps, source control, CI/CD, but at the moment, everything training-wise is done manually. Once that we have a good foundation, we can go into automating. So we can automate the training of the models, introducing ML pipelines. And then once that you have that, then you can move into closing this loop that we saw by introducing a lot of monitoring, which is going to allow you to retrain automatically. Or even, for example, you know, you can see the drift of your data, change the training depending on this, and so on and so forth, which I will talk a bit more later. Also, something that we want to focus here is that MLOps is just a framework, it's just a tool, and we really believe that without a proper strategy, it's a bit of a useless thing. So we want to here first give a really simple strategy on how we would approach MLOps to a particular use case. The first thing is identify pain points. Maybe your use case has 1, 2, or 3 things that maybe is really hurting the value that this use case is going to bring, and that's the first thing. You know, really see what is hurting your use case. Then, because you might have more than one thing, you first need to really prioritize. What is the thing that I really need to start because it's really hurting me and it's easy to fix, let's say. Then start small. I think we've said it before. It's something that we really believe in Dataminded. It's not from us, but this mantra of make it work, then make it beautiful, and then make it fast. No? So really make it small, keep it simple, don't over-engineer, and then if you need it, you can go and you can scale. Yes, as my colleague said, you know, there is a really big puzzle, you know, and every piece, it can give you so many headaches, so many pain points. There are general guidelines on how to fix each of these pain points, but what I really want to emphasize here is that the effort needed and the value that it provides to fix any of these pain points depend on your particular use case. It's not that, you know, making your model fast is going to be the same for my use case than for your use case, and that's really important. So now I'm going to go quickly over, you know, the problems that Mario showed in the beginning and some solutions. You say, okay, performance degradation, what do I need to do? You need to, of course, have monitoring to be aware that the performance is going down. Then you need to put alerts. Okay, imagine accuracy is going below a threshold. Then trigger automatic retraining of your model. Long training to production cycle. Automate everything, CI/CD, orchestration, and so on and so forth. Not reproducible training, version everything. Version the model, version the data, version the code. About data, we have talked, I think, a few hours already, so you have more than enough on how to model. You have model registries and codes, you have kits, and whatever you like to use. Data collection, again, this is really not an exhaustive list. There is a lot of things that can go wrong in here. One, data drift. Again, in order to see that your data is drifting, you first have to monitor it. And then if you see that that's going down, then you either need to retrain your model or then go back to the drawing table and see, maybe I need to do again future engineering to adapt to my changes. Hard to track feature changes, add a feature store, and lineage tracking. It's all about automating things and monitoring things. You know, that's I think the idea behind MLOps. Finally, infra. Here there is something that I believe we are really opinionated in Dataminded. We believe in the idea that everything should be with codes, and infrastructure is not an exception. So we have things like Terraform, for example, that allows you to say, okay, I want this kind of infrastructure in my cloud provider. I put it as a code. I can version control, I can test, I can deploy, and if I remove something from my backend, I can do it in the code. I don't have to run manually clicking things. With this foundation, you can go to, for example, high infrastructure codes. Then you can do something like dynamically resource allocation, which is going to be easier if you have infrastructure as codes in place. And now I think at this point, maybe everything sounds a bit of, too abstract. So we decided that a good idea, to give a taste is to go through an example use case that we found, which is about doing better recommendations using an MLOps. As a bit of a context, we imagine this scenario. So we have a website, okay, where different users, they can navigate this website. Imagine something like, of course not Netflix, but something like Netflix. We can track what the users do. Based on that, we can train an ML model and then give better recommendations to the user, like, watch this new movie because you watched this other movie that was related before. And how do you actually do this? In this particular case, how it was done is by the users navigated the website. We have tracker in place. In real time, we get what they do in a table. Then every night we run an ETL pipeline that is going to pre-process the data and dump it into a process events data set. Then is when we turn and we use the ML model that is going to take this data as an input, and as an output is going to give the recommendations. And finally, the next day, we update the recommendations per user. In this particular use case, we found an already quite mature implementation for several reasons. First, they were already using one of the 3 big cloud providers. Second, they had orchestration in place both for the ETL pipeline and for the predicting recommendations with the ML model using Airflow. This really important for the next slide is that this orchestration happened once per day at a batch processing during the night. And finally, they also introduced something super important in MLOps, which is Docker. So they containerized their model so it could run in whatever computer. However, this setup has 3 main pain points that we found. The first one is that the data had both environments, dev and prod. However, the model only had a production environment. So that's something that to some of you might be like, oof, that's a red flag. Another really important one was no performance monitoring. So at these moments, we saw that, okay, you are creating recommendations, but you don't know whether your recommendations are better than random predictions or not. And finally, slow predictions. They really took too much time to each prediction to be computed. So we've seen something similar, I think, from Jelena. These kind of matrices, they are really simple conceptually, but for me, I think they're really powerful. So now we can go to this matrix and go pain point by pain point. First one, single model environment. Is it important? Yes. Is it a must-have at this moment? No. Why? Because at this moment, they are a bit lost. They don't have performance monitoring. Like, why do I want to do many fancy things with my model if I don't even know if my new model is better than the old one? So for us, a priority was the monitoring of the performance. Finally, slow predictions. Here again, there could be some debate, okay, if it would be actually Netflix that they are doing real-time predictions, then of course you need speed. But in this use case, the predictions were computed during the night, so we had a window of 8 hours to get the predictions. For this use case, it was okay, it took 4 or 5 hours. If they would want to go into real time, or if the number of users in the website would grow to double or triple the number, then it would be an issue, and then these fast predictions should move more towards the upper left corner. And now simply what we're going to do is show how we could implement the monitoring in this particular use case. Again, I think a topic that we've seen today recurring is we love to take ideas from software engineering, okay? And one of them is A/B testing. Simply put, what you do is, if you have a website, for example, or an app or whatever, you split the traffic of your website, in this case, into 2 groups. the A group. For example, in this case, it's going to see the predictions from your model. And the B group is going to see random predictions. Then you see how well each model does. And then you compare and you say, okay, indeed, my model is doing better than random. I'm going to keep working with my model. And how do we do this in this particular use case? This, of course, is a really simplistic drawing. Important, we could delegate the A-B distinction into the data processing instead of doing it at the upside. Why? Because we are not doing real-time predictions. If that would be the case, and you have to introduce something fancy like a load balancer that would redirect to different endpoints during the prediction. So basically, we do the same thing. Okay, the users navigate, get the events, process them, and now we're going to feed them in parallel into two models, and we are going to dump the predictions into a table that is going to be tagged with the model. Okay, these predictions are from model A, these predictions are for model B. And then we're going to feed back the predictions into the site. The important thing here is that the fact now that we have different predictions that are tagged by the precedents, model A, model B, versioning, you can imagine something like this. It allows you to introduce monitoring tools, for example, like Grafana and Prometheus, to come up with something like this and say, okay, every day, based on the model that you have used, do the users stay longer in the website or not? If so, then we would prefer the model that the users stay longer with. And with this, for me, it closes the MLOps loop, and also it opens the possibility to really innovate. Now you can see performance over time. Is the performance going down? Do we need to retrain the model? Now my data scientist, he wants to play around with a new embedded model. You want to do something new? Okay, that's fine. Create it, go to A/B deployment. Let's test the hypothesis and see, okay, your new embedded works better in production data or not. And finally, to summarize, how do we successfully build with MLOps? We think that there are three key aspects here that summarize what we've said today. First one is everything that you do in production, you want to make it reliable. How do you do it? Versioning everything that you have, versioning the data, versioning the codes, versioning the model. You want it to make it robust. You really want to make sure that everything is working and that you introduce monitoring, really, wherever you can introduce monitoring. Why? Because monitoring allows you to go from a reactive way of solving issues, okay, my pipeline is failing, now I have to fix an issue, into a proactive way of fixing an issue, which means that I can fix an issue before it actually happens. That's what monitoring gives you. And finally, make it manageable. Yes, we've said a lot of bunch of things, DevOps, MLOps, too many frameworks, but start smart, start small. Go really to your use case. First, see what is the thing that is really hurting your use case. Go to the first one, fix it, iterate from there. Don't go crazy with frameworks, really. Go one by one, start small, and keep working from there. And I think that finishes our talk today.